Ever wondered what's really on the other side of a black hole? Get ready to have your mind blown, because what we know might just be the tip of the cosmic iceberg. Hey everyone, welcome back to our channel. Today, we're diving into the enigmatic world of black holes. We often imagine them as colossal, pitch-black voids in space, sucking everything in towards a singularity where it all gets squished. But what if we told you that's not quite how it works? Let's unravel the mysteries behind these fascinating cosmic phenomena. Black holes are some of the most complex and intriguing objects in the universe. They form when a massive star, about 10-20 times more massive than the Sun, runs out of fuel and collapses in on itself, creating a supernova. But here's where things get complicated. Our current understanding of black holes uses different theories for different scales. Quantum field theory explains the behavior of particles, while Einstein's general relativity handles astronomical scales. But black holes bridge both worlds, making them especially tricky. To put it simply, if you were to compress the Sun into a black hole, it would have to be squeezed to a radius of just about 1.8 miles, 2.9 kilometers. For Earth, it would need to be the size of a ball with a radius of 0.35 inches, 0.88 centimeters. This threshold is known as the Schwarzschild radius. But what happens when an object's radius is zero? This is where the concept of a singularity comes in, a point where traditional calculations break down. Consider a thought experiment. Imagine tiny bits of matter floating in space. Gravity pulls them together, and as they compress, an event horizon forms, a boundary beyond which nothing can escape. This is called a Schwarzschild black hole. But what happens when you cross the event horizon? No matter which way you try to move, you'll be drawn toward the central singularity. Things get even more complex with rotating black holes, or Kerr black holes. These have two distinct horizons and ergospheres, regions where spacetime is dragged along by the black hole's rotation. Here, particles can escape with more energy than they entered with. This phenomenon, explained by Stephen Hawking's theory of Hawking radiation, suggests black holes could eventually evaporate over unimaginable timescales. But if singularities aren't real, what lies at the center of black holes? According to Roger Penrose's theorem, singularities are inevitable in general relativity. This means that, under the laws of physics as we understand them, the immense gravitational forces inside a black hole should crush everything down to an infinitely small point with infinite density, known as a singularity. However, a recent paper by Roy Kerr challenges this notion, offering a different perspective on the nature of black holes, especially those that rotate. In Kerr's model, rotating black holes, also known as Kerr black holes, don't have point-like singularities. Instead, the rotation of the black hole alters the structure of spacetime around it, creating what is known as a ring singularity. Instead of matter falling straight into a central point, it follows complex, spiraling paths due to the intense rotational forces. This results in a ring-shaped structure at the center of the black hole. This perspective implies that the original star that collapsed to form the black hole isn't entirely obliterated into a singular point. Instead, its remnants are stretched and twisted by the extreme rotation, possibly existing in a highly distorted state within the ring singularity. This means that inside the heart of a Kerr black hole, the collapsed star might still persist in some form, albeit unrecognizably altered by the extreme conditions. Imagine a perpetual centrifuge isolated from the universe, filled with swirling matter and ethereal light. It's a mind-bending concept, but one that challenges our understanding of black holes. What do you think about this new perspective on black holes? Share your thoughts in the comments below. If you enjoyed this video and want to learn more about the mysteries of the universe, hit the like button and subscribe to our channel for more fascinating discoveries. Thanks for watching, and stay curious.